Okay guys, so here's a guide video for this problem. This is, I forget what this might be the third one. The final countdown for your response question. Okay, so the inside of a funnel of height 10 inches, all right, so this whole height is 10 inches, has circular cross sections. Now guys, notice these cross sections are cut horizontally, like you'd have to slice through horizontally to see the circles. Okay, at height h, the radius of the funnel is given by that, where h is between 0 and 10. Yeah, so down here h is 0, and up here h is 10. The units of r and h are inches. All right, so first you want to find the average value of the radius of the funnel. Guys, average value you need to know is, it's this formula. You do 1 over b minus a, the integral from a to b, and then here you put like whatever you want the average of, all right? So we want the average radius. The radius is expressed in terms of h. So our variable is going to be h. And you could also tell, yeah. All right, and here's the h interval. So it's going to be 1 over 10 minus 0, the integral from 0 to 10, and then in here you're going to put the radius function, which is 1 over 23 plus h squared. And then you need to have perfect notation, if you can. So at the end, the variable here is h, so dh. Okay, now this is a non-calculator section, so the only way we have to do this is with the fundamental theorem of calculus. So I'm going to pull out the 1 over 20, and that's going to be 1 over 200. The integral from 0 to 10, 3 plus h squared dh. So this is 1 over 200. This is the fundamental theorem of calculus right here. Antiderivative 3h plus a third h to the third. So this is 1 over 200. 10 goes in and we get 30 plus 1,000 over 3 minus 0. Okay. And then what I did, guys, I got common denominators on the inside. So that's 90 plus 1,000 over 3. So this is 1,090 over, what is that, 600, and then I can, divide by 10. So 109 over 60. Now you have to be careful with your units here. So what are the units? This is the average value of the radius. So that's like the average radius. How is the radius measured in inches? Okay, so right there. Alrighty, now part B, find the volume of the funnel. And guys, this could be very confusing, but if you're asked to find volume, the way that we find volume in calculus is with this formula. So this is for part B. So volume is going to be either the integral from x equals a to b, area in terms of x dx, or it's going to be the volume, the integral from y equals a to b, area in terms of y dy. And guys, it's really basically we're using this one because the slices, the cross sections are cut horizontally. And Y is like H here. And that's like really good news because this radius is already solved for in terms of H. And the area of each cross section is going to be the area of a circle, so pi r squared, and the radius is already solved for here in terms of h, so we're going to use, so everything's going to be in terms of h here. So we want volume equals the integral from h equals 0 all the way up to 10, the area in terms of h dh. Okay, now the area in terms of h here, it's going to be pi r squared. All right, that's going to be the radius. And we know the radius is 1 over 20, 3 plus h squared. All right, let me simplify this like a little bit. So this is, that's pi over 200, 20 times 20. And then it's 3 plus h squared squared. Now, you're going to have to take the antiderivative of this right here. If you leave it like this, you might think, oh, I can let u equal the inside or something, but that's not going to work because the h's wouldn't cancel if you did that. So all we're doing here is squaring a binomial. So this is pi over 200. And then, so when you square a binomial, you could write the two parentheses and distribute. But this ends up being 9 plus 6h squared plus h to the 4th. All right. So the volume is equal to, so I'm just going to put this area inside of this volume formula. And this is a constant, so I'll have this out front. So pi over 200, the integral from 0 to 10, 9 plus 6h squared plus h to the 4th dh. Fundamental theorem of calculus. 9h plus 2h cubed plus a 5th h to the 5th equals pi over 200. I'm going to plug 10 in. 90 plus 2,000 plus, guys, I did it like this. Like, I did it like 10 over 5 times 10 to the 4th. That's how I thought of it. Because 10 to the 5th is just 10 times 10 to the 4th, and I saw that these were just gonna cancel and make 2. So pi over 200, 90 plus 2,000 plus 2 with 4 zeros. So this ends up being 22090 pi over 200, which ends up being 2209 over 20 pi. Okay, now this is volume. This is volume. So what are the units on volume? They're units cubed. So this is inches cubed. Inches cubed for the volume. Okay, now we're going to do part C. Part C. The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time. So guys, we used to do this like no want when thing sometimes, and you could still, let me do that in case it helps anyone. You don't have to organize it like this though. No want when. Maybe you don't like this actually. I don't know, I'm sorry. All right, let me just write down what I've got. So h equals 3, let me say not constant. No, I would label the constants, that's what I would do. So h is 3, but not always. H is 3 at a certain moment. And then the radius of the surface of the liquid is decreasing at this rate. So we know that dr dt is negative 1/5, negative because it's decreasing. And then we want the rate of change of the height of the liquid. So we want dh dt. All right, so let me write my radius function down. So r is 1/20, 3 plus h squared. Now I'm going to take the derivative of every term, and I'm going to need a prime after every single derivative because t is the input variable. So r and h are both functions of t. So the derivative of r is r prime. I can just bring down this 1/20th because it's just a constant multiple. And then I could do the derivative of this. Or you could have distributed the 1/20. That some people might like to see that. The derivative of 3 is 0. The derivative of h squared is 2h h prime. So r prime is 1/10 h prime. We want h prime. So we need to be able to put something in for r prime and h. So in for r prime, negative 1/5. And for h, 3. So 3/10 h prime is negative 1/5. H prime is negative 1/5. I'm dividing by 3/10, so keep change flip. So h prime is negative 2/3, but you need units. So this is a rate of change, so it needs to be something per something. So the height is changing in inches per, what does it say? Second, inches per second. Inch per second. Okay.